Okay, welcome back to EL 164. Today we're going to discuss, we're going to have the lab. In the lab, we're going to discuss the Control Logix 5000, RS Logix 5000 software. We're going to be showing some of the different techniques and reviewing some of the things that we may have already discussed and learn some new aspects of it. So without any further ado, we're going to go ahead and get started here. Going here. So here we are. I guess I should probably step back one and come here and go down to 5,000. Go ahead and click on that so you can see that whole process take place. RS Logix 5000. So we click on that. We have a process of opening that up. Noting that down here it does actually display the version that we're at, 20.01. Goes to a quick start menu. I'm going to skip all that and go right to File, New. When I go to File, New, the first thing it does is it says New Controller. So at this point we're going to develop our controller. As you can see, because the last time I was online with this thing, it selected the exact same one, but I do have the choice of all these different ones. So I'm just going to stick with what I got. The L16ER BB1B. We're going to call this Lab3. How about online? I'll give this a quick description. Say review of micro Logix controllers. Zero expansion I/O. I talked about this last time. Well, zero modules because there's a fixed I/O unit, and when you have a fixed I/O unit, you can have modules that you can expand. You can add a high-speed counter module. You can add an input module, an output module, that kind of analog and digital, that sort of thing. But in this particular case, we don't have any expansion modules, so we're going to leave that module set to 0. Hit OK on that. That brings us into this new screen here. Now we are actually looking at the control organizer. We can see, as you can see, I highlighted the same point in the lab report. Here we've got the 769 L16ER BB1B here. It shows up here in the I/O configuration. It also even shows up here as part of the name of the project. So you have multiple indicators of where that information is at. Let's go down here. Let's pop this guy over here. So the next piece of this is I'll bring this right on over here so we can see that. So I collect the PLC, powered up both components. I connected the Ethernet cord, that same cable that I showed in the last online session. Where we've got the RJ45 connections on both ends. So I connected one end of the PLC, the other end of the computer. Once it was connected, I had this component down here on the bottom right-hand part of my computer. I don't think you can see it from where you're sitting, but I highlighted it and circled it. So when I plug the Ethernet cord into my PLC, it shows me as being connected. So that gives me an indicator that I am connected to the hardware circuit. So that's a good indicator there. So the next piece there is I clicked into the RX 5000 and I went to the new, found the processor number, entered the name for a program, selected 0 for expansion I/O, as we did. I pressed OK, and now we are at that very point where we're highlighted in the yellow. So, so now that we know that we have our program configured properly, we know this because when we go online, let's see here. Oh, wait a minute. We're not going online. The first thing we have to do, now that we have our, that's where I'm missing. Okay. So now that we have configured it properly, we need to develop our tags. So the first thing we have to develop is tags under what title? Where do we create our tags? What title do we have to use? Controller tags, not program tags. We don't want to use this one. We want to use controller tags, okay? So here we go into controller tags. And now we want to create some tags. The first tag we need to create is what? Called bits. So we're going to do a Boolean bit tag. So I'm going to come in here. I'm going to say right click on this, say new tag. I'm going to call this bits. I'm going to come down here. I want bits to be what? Boolean. So I'm going to come in here and type in bool, B-O, and it becomes Boolean right here. Hit OK for that. Now I have bits. It's Boolean, and I'm going to go ahead and create that. If I go over here and create and open new, then it keeps this page up for me. So as you can see, it creates bits in the background, and I got this. The next tag I need to create is called integer. Let's see what integer does for us. So I'm going to create a tag called integer. Come into here, type in int for integer. Okay for that. Let's also go ahead, create and open new. The next one of this I got to create is what? Double integer. So we'll come over here, look at double integer. Double integer. And down here it's got dint already for indicating double integer. Create. Open new. Okay, the next piece of this it asks for is to create an alias tag. What the heck is an alias tag? Oh, one step back. I will go back here. Wait a minute. I'm going to go ahead and cancel this for a second. There is an indicator here asking for the number of bits. So the number of bits in the bits category. Let's take a look at that. Let's see if we go to edit tags. We see bits. How many bits is there? It's 1 bit of Boolean in the bits. Now, as we saw in this last chapter, 1 bit still consumes 32 bits, but it's only allocated 1 bit of that whole word. So we're only looking at 1 bit in that application. The next one is the integer. The integer is how many bits? It is 16 bits, 0 to 15, gives us 16 bits. And the next one, double integer. If you can imagine, integer is 16 bits. Double integer is going to be what? Yeah, you guessed it, 32 bits. So we're at 32 bits for double integer, 16 bits for integer, and 1 bit for bits. Okay, so the next piece of this is it requires us to create an alias tag. So what is an alias tag? Let's see about going about creating that. So we come over here, new tag. We're going to call this alias. We do go about creating an alias tag. We come in here, we go to type. Instead of base, we're going to go to alias. Alias for what? So let's just pick a simple input here. Data 0, local 1, data 0, Boolean alias. So we go ahead and create that. So now we've created a bit called alias. It's associated to an input. So now whenever this input turns on, it's going to turn on this tag. So this tag essentially is this location now. So when you are requiring this location in a PLC program, instead of typing in local 1 I data.0, you type in alias and bam, you get that address. Pretty cool way of doing it, not bad. Okay, next step of the process is create a produced tag. Oh, and what does the alias tag do? It gives you the what? Ability to reference a data location, like data 0. So you can it references inputs and it references output. It can be used for reference outputs as well. So the next step of that is create a produced tag. how do we go about creating a produce tag? So let's try that next. File, new tag. Next one on the list is a produce tag. So I'm going to call this produced. And alias for, okay, so connection, and then we put some value in here. It's got 1, but you could put 10. The way I understand it is you usually have about 10 in there for if you're developing a produce tag, so it has more than one location to write to. And then the rest is just go ahead and create that. What this does for us is it gives us the opportunity, as you can see here, it's produced one word. It gives us an opportunity to write this information to other locations. As I mentioned in lecture, you're going to run into situations where you have multiple PLCs tied together in a network. In this network, you've got to share information between one PLC to the next. In order to do that, you have to create what we call produced and consumed tags. These tags are common only to Allen & Bradley. There's other forms of PLCs use different techniques to do the same thing, but the Allen & Bradley solution is to create a produced tag and a consumed tag. As you can imagine, produced means from the local PLC that you're working with and the location you're at, you're producing information to send to other PLCs or other areas. When you're thinking consumed, the PLC you're working with is consuming information from other locations. So it's information coming from other PLCs, maybe from some other touchscreens, maybe a few other different areas like that. So consumed means you're consuming that information. Produced means you're producing that information. That's all information based from a PLC that you're working with. Okay, so the next piece of this. So a consume tag, again, as I was talking about produce tags, a consume tag is a tag that's going to consume information created by other processes. So let's take a look at about creating a consume tag. So we got in here, we're going to come in here, we go to tags, create new tag, and we're going to call this consumed. Consumed, we'll just leave that, and we'll come over here and go consumed. Now this particular one means I am going to consume information from other processors. I got to come in here and select where that processor's at. So I have to be online connected with other PLCs to extract this information. If it's not available, I can't click on it here. So I'm not connected to any other PLCs here locally. So I'm unable to set this up correctly. So what it's going to do is it's going to give me an error when if I try to set this up because it just doesn't exist. There's no processors to connect to. So if I hit OK here, it's going to give me trouble here. So I cancel this out and I go ahead and create this, it's going to give me trouble here. So I cannot create a consume tag without having an address location or a processor connected to my network to connect to. There might be some tricks around it that some of these Allen Bradley guys that are really sharp know, but I am not aware of a trick around that at this moment. So we're going to just go ahead and cancel out the consume tag because I cannot create it at this point. So there is how we produce a consume tag, and why I can't create it is because we're not connected. So the next piece of this, make a tag an array in one dimension. So let's start with bits array of 1. So bits, I've got bits, 1 Boolean, right? So I got to be offline and edit mode to change these. So I come over here, I click on the 3 dots there. You see dimension 0 here. If I put a 1 in there, it gives me 32 bits. I come in here, hit 1, I hit it, it gives me a 32. What they're doing, what Allen Bradley has done, is they understand if you put 1 in there, that means that you want 1 full word of it, I believe is what they're asking for. So, So until you put a 33 in there, it doesn't give you two words. So basically it says any number other than 0 and less than 31, or 32, excuse me, it'll give you one word of information. If you put a 33 in there, it gives you two words of information. I'm not sure what Ellen Bailey was thinking there, but it does work, and that's so if you wanted all 32 bits or one word of bits, just put a 1 in there and it gives you 32. So you don't have to type in 32, I guess that's what they're thinking there. Integer, they're asking for 10 of those. So if we come over here, look at this guy again. So array integer, we want an array of 10. So dimension 1, array of 10. We come in here, we put a 10 in here. We hit OK for that. Enter. Now we break this guy open. Now guess what? I have 10 words of what? 16 bits each, right? So we 10 words of 16 bits each. So that's the next question, was how many bits in an array. So 10 words times 16. So the next one is a double integer array of 10 number of bits. So we go in double integer here, click on this guy, we put a value of 10 in there, we hit OK, enter for that. So now if we go here, guess what we have now? We have 10 words of 32 bits. So we have 10 times 32 for the number of bits in that one. 10 times 32 is the number of bits there. Okay, so for the next piece of this, we're going to go, I took that away too fast. We're going to go to communications and do the pull down menu to select who's active and find the PLC we're talking with. Let's see what that's all about. So I'll go into communications, come down to who's active, and then you got to find the PLC. See, I already know that I'm under Ethernet IP2. So I just happen to know that, so otherwise I would have some troubles. And I know that my IP address is 10.0.0.30. So, and I'm talking to this processor here. So there's a couple pieces that I already know. So you're going to have to get underhand. You're going to have to start understanding some of these IP addresses and that as you go online at your office or wherever you're working, and to understand, get a better understanding of some of this information. Okay, so at this point, I'm going to download all this information. When we're, again, I think I mentioned this before, when we're talking about PLCs, we're talking about the information in the PLC. So when we say download, we need to take information here at a laptop and download it to the PLC. And when we want to upload, we want to extract information from the PLC and bring it to our laptop or our computer. So think of downloading to the PLC always, and that'll help keep you organized as far as the process of uploading and downloading. So we're always downloading to the processor. So we're going to select download here. Yes, this is all correct. We're going to download that. And yes, we want to switch it back to my remote run mode. It's already in run mode, so yes, we want to switch it back into run mode. Okay, so now we are in run mode. We've downloaded the processor. We have we've selected this download button. We're in pretty good shape. As you can see here from this highlight here is that I've got all green lights, nothing flashing, nothing red. And so now we're online. Woo woo, we're in business here. We got some good stuff going on here. So next piece, we need to what? Start developing a program. So select main program and main routine. So we got main program, main routine, and voila, we're there. So bringing back that document here, main program, main routine. We are looking the same as we are in the lab report. This is going to be the location where we're going to start developing our code. Okay. So the next piece of this, it says develop a seal-in circuit or start-stop circuit using the following components. Start program, or start PB, it's going to be normally open. Stop PB is going to be normally closed, and motor is going to be a relay. So what are we going to do for that? First thing I want to do then here is I'm going to create some alias just for fun, just so we can get some more practice at that. So a new tag. We're going to come in here, we're going to call this start PB. It's going to be an alias. We're going to select alias for what? We're going to come in here and go data. Oh, I missed the wrong button here. We'll do, how about, why not? 8. Go ahead and create and open new. We're going to create stop PB alias 4 data about 9, create and open new, stop, oh yeah, and then relay or motor, I guess we call it motor. Alias, and this is going to be the output, data 0, create. So now we've got our tags to create this. Now we want to create our logic. So let's go in here and create some logic. So we got a start, stop, output, and now we got to do our branch circuit. So we're going to slip this into here and this into here. Standard start-stop circuit or seal-in circuit. So now let's fill in the addressing. So come in here, instead of typing in what? I blah 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 blah, I'm going to type in what? I'm going to type in start push button. And notice how that fills in local 1 IData 8. So I'm going to come in here and hit stop push button. It fills in local IData 9.9. And then finally the output data. I'm going to come in here and say what? Motor? And it turns on this guy. I can also just take this and drag him over here and it populates that guy. Ooh, I got eyes here. Eyes indicating that I did this all online. Whoops, I wasn't supposed to do it online yet. We're supposed to wait till online editing for a little longer, but I'm already online, so we might as well show you what you got to do here. So the eyes indicate that it is a program in process. I've got it written in my laptop, but it's not in the processor, and it's not proven out this time. I can click this little button here. At that very moment, I'm able to take this information, finalize the program, and send it to the PLC. So I go and hit yes for that. And now the eyes go away, I'm green on both sides, and now the program is in the PLC. It's just equivalent to downloading. So now at this very moment, I can do some testing here. So I've stop push button. It's actually a toggle, so I'm going to go ahead and toggle him on. So now my stop is on. And if I hit my start button, just as a brief bump, that guy comes and seals this guy in. So what happens is it closes that contact. As you can see, this is still on. This is on now, and this is transferring power to this guy to keep him on. The only way to turn him off is what? By hitting that stop button. And that drops him out. Standard start-stop circuit, using aliases to operate the operation there. So we're able to, instead of having to type in all these crazy addresses, aliases work really nice for that. So let's go back to the lab report and see what it has to say about all that. Okay, so now we got a normally open, a normally closed, and a motor for relay. So we've got all that in place. We got to draw a program with a sealant circuit or start-stop. So you could take this circuit and draw that in there as a PLC program. And I want you to draw a hardware seal-in circuit or stop. So take the same circuit and show it as a hardware circuit. So show the push button normally open, show the push button normally closed, and show the relay. And label them all appropriately, if you would. So here, actually, here is we were supposed to use data 0, data 1, and output data 0. I used 8 and 9. That's the start and stop, but you can use 0 and 1. It doesn't matter. It's the same principle. I developed the program, and supposed to download at that point. And we were actually online, so we skipped a couple steps there. But you get the idea. We went through that whole process there. Okay, so the next piece of this is we need to develop a program to turn on multiple coils using integer 3 binary bits. So let's see how we're going to modify this program to do this. So 0, 4, 8, and 16. This time I'm going to actually go offline. So input 8, input 9. So we turn on all these bits when both inputs 8, A and B are on, which is input 8, 9, and 10. Let's see here. Let's go ahead and create some new tags here. I'm going to call this A. Go ahead and select him. Oop, I forgot to do create new. I'm going to create B. And C. Okay, so I've got 8, 9, and 10. I'm going to go here. I'm going to click on this and do what? A, B, I got to add another contact here. C, and I got to move him here. Oh, undo. That did not work. There we go. The requirements here are A, when both A and B are on, turn on coils, integer, blah, 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 when both inputs A and B are on. Turn off coils when input C is turned on. So here we are. So when A and B are on, turn off when C is on. So when C is on, so we got to switch him out to a XIO, right? When C is on, you want that to open up. Next piece of this, binary bits 0, 4, 8, and 16. So here we go, here we got to go, here we got to put a branch in there. How many do we need? 1, 2. Oh, I can undo that one. I want to do it this way. 4. So I'm going to go here, put a coil, here put a coil, and here put a coil. Coil. All right, now I have to do bits 0, 4, 8, and 16. So if I come in here, go to bits 0, what was the other one? 4, 8, and the last one was 16 and 16. You can see as I flow through that, you could actually, I could go all the way up to what? 31. So now this has to come on and stay on until we're done. So I can grab any one of these bits as a sealant circuit, because what? They all turn on at the same time, right? Because they're all in parallel. So let's go ahead and download that. Okay, so right now I have, looks like I got B on. I'll turn him off. And I got C off. So if I turn C on, you'll see it trip out. So I'm going to turn A on and B on. We should see all 4 of these bits turn on. I turn A and B off, or A or B off. We will see they stay on. It is not until I hit C that they turn off. So here we are, we got bits 0, 4, 8, and 16 on. Okay, so here we are, we've completed the task of developing the lab. Last piece of this is I want you to be able to determine the hex value of this word. So by doing so, you can break the word into 4-bit increments, and by doing so, you'll be able to determine what the hex value of that is. Okay, so next piece of this, we're going to move into developing step 7 here, or developing the next ladder program here. So let's go ahead and dive right into that. Okay, as we can see here, here's the program we previously had in there. I'm going to go ahead and take this offline. I'm going to go in here. I'm going to modify this program now. So in this time, we have to do what? We have to turn on coils for double integer bits 1, 9, 18, and 31. So let's go in here, find double integer. Close up bits, double integer. Integer 5, so it's going to be down here, integer 5. Note in here, it says double integer 5 right here, so that means it's word 5. Bits 1, 9, 18, and 31. So let's see about going there. So I'm going to go over to here, and I'm going to enter double integer 5, 1, I think I can do this. And I'm going to do this. Copying is so much faster than developing code. So whenever you can copy, always copy. So 9. This one's going to be 18. And the last one is 31. Okay, so now we've got the 4 bits. Turn on coils for double integer 5, bits 1, 9, 18. when bits A or B are on. Okay, so when A or B are on, let's see about this. So we've got, right now I've got A and B. So I'm going to come in here, put our branch in here, move him over to here. Maybe, there we go. And I'm going to move him right there. Bam, A or B are on. Okay, we've got A or B. What else? What's the next piece of this? When C turn off the same bits that we turned on when input C is turned on. So we've got, so input C turns on, we're going to drop those out. And what? Because we have a sealant circuit, we have to grab what? We have to grab one of these. We can grab any one of them again like we did before, but I'm just going to go ahead and grab that one. So that gives us our program for step 7. Let's see how that downloads here. Let's see if we get any errors or anything of that nature. Oh, that looked like that went well. No errors. So now, if I turn on input A, I turn on all the outputs, and input C will drop them out. Or I turn on input B, all the outputs turn on, and if I turn on input C, it drops out. Sweet. So we're in business. So we got step 7 programmed. It's in place. We got input 7. I'm supposed to switch the inputs 7, 5, and 3. I can certainly do that as easily as well. We come in here, we go back offline, or we can do this online, but we'll just go offline here. And wait a minute. Okay, so to change the addressing of this, I was thinking I could change it here, and I might edit a property. See, right here I can go into the properties. So the challenge for 7 was we have to have the 7th input, the 5th input, and the 3rd input. So I just got to come in here, go to data, select 7, apply, okay, properties. The next one was 5th input, so I come in here, go to data, grab the 5th input, okay for that, and then C, I had changed the properties on this one. Properties, and we change that to the 3rd input. So we got 7, 5, and 3 indicated here by input A is 7th input, B is 5th input, C is 3rd input. So, all right, let's see what we got going on here with that. So we go ahead and download this. Again, in order to make these changes, I do have to be offline. Keep that in mind. So I'm going to download this information. Yes, there we go. Okay, as we can see here, 3 is on already, so let's see if I can turn 3 off. Okay, and then I hit A. 7 is A, and 7 is not a push button for me, so I have a problem here. I got to select a different input. I didn't realize that 7 was not an input. Let's modify this a little bit. Let's go in here, go back offline. My mistake. I selected a signal that's not available, so I'm going to go ahead and edit properties here. Let's make that data a 6. Okay. Seeing as how 3 is normally closed, why don't I change that one to a normally open? I can just change this guy here to an XIC, and that's going to solve my, because my 3 is a normally closed push button. I have to hold it down, so it's on already, being normally closed, so I don't. So that's, this is a good exercise in understanding normally closed versus normally open push buttons. Let's go ahead and download this. Yes. Okay, as we can see now, A is on, and that is input 6. Apparently that's a normally closed as well. Okay, so I got to press that and it turns it off. And if I hit C, which happens to be bit 3, is also normally closed, that drops it out. I got 2 normally closed push buttons, so what? I got to press them both to get them to turn off. And if I want B to come on, I have to, what? Turn on C and press number 5, which is a normally open. And bam, there we are. We got all 5 outputs on. So one of the points that I wanted to share with you guys is looking at the tags. We go to the tags here. We are in monitor tags. We're going to go to double integer. And notice how it gives us a decimal value. We've got a decimal value here. This would be the value of this word in decimal. If we expand on this, we'll see all the ones and zeros that we've turned on. If we wanted to display this in a hex, all we got to come over here and just display this in a hex. And there's the hex value of the same number. So if I remember right, there's a couple of questions regarding that in the lab. So that would solve both those questions for you. Okay, moving along. The final question here for the final piece of the lab is step number 8. So let's move right into step number 8. I'm going to go back offline here. Go to the main routine. This time we got to turn on a couple of integer bits, integer word 2 bits. I'll bring this over here so we can see this. So we got to turn on integer 2, and we're going to turn on some bits 12 and 24. When A and or B and C are on, turn off coils, blah, 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 when both D and E are turned on. So we got a little more challenge here. This is not as easy as it sounds. This is a little bit of a challenge here. So let's start with the 4 bits, I guess, like we did in the previous one. That works pretty easy. So integer 2 bits 7 and 21. So here we go here. We're going to go into this piece. We got to go close the double integer. We're going to go to integer. Integer 2, so this is integer 2. Press the button too many times here. And we need bits 7, 21. Oh, I screwed up. Look at that. Integer 7 and 21. There is not a 21. There's only we end at 15 for integer, right? I screwed up in my lab report here. My mistake. I was thinking I was dealing with 32-bit words. Let's go with 7 and 13. How about that? My mistake. 7 and 13. Okay, so let's go. So integer 7 and integer. Oh, I'm going to drag him down here. And integer 13. Okay, so I've got that. Next piece is I got to do bits 12 and 24. Now I already, oh wait a minute, this is a 32-bit word, so I'm good there. So 12 and 24. So let's go ahead and grab the bits next. So we're going to go here. I'm going to go select bits. So right now we're in double integers again. We want to close double integers. We want to go to bits. We want bits 12. I'm going to drag this down here, copying that, and 24. Okay, so let's look at this. We got integer 7 and 13, and we got bits 12 and 24. So we've got the outputs figured out. Now, when bits A or B and C are on, A or B and C, what do we got to do there? So A or B, we've got that configured already, and C, we've got that in there as well. I think we're in pretty good shape here. So all I got to do is move this guy here. So that takes care of that. So now A or B, A or B, and C. So now we got A or B and C all set up correctly. Now how do we turn these guys off? All right, how do we turn these off? When both D and E are turned on. So when both D and E are turned on. So that's kind of tricky. Let's see how we go about doing that. We got to come in here. We got to go normally closed. You know, we haven't created a D or E yet, have we? We got to create our D and E yet. So let's go back to the process of that. I'm going to escape here. I'm going to come into controller tags, new tag. I'm going to call this D. Oops, caps lock D. I'm going to do an alias again. This time the D is supposed to be what? The second input. So I'm alias this guy, so the second input. Let's go down here to inputs, data, second input right there. Bam. Create that. Oh, I forgot to hit the create and start new. Now I'm going to go E, alias, inputs, data, and that one, E, is supposed to be the fourth input. Create that. So now I come into here and I want to create another tag, and I want to go, oh, this would be when D or E are on, we got to turn it off. Or was that D and E? Let's take a quick look at that. That's D and E. I think it's D or E. D and E are turned on. So D and E are so it's and. So it is the and statement. So that means that both of these have to be on in order to turn this off. If I turn this one on, it would drop it out. If I turn this one on, I'd drop it out. Let's take a look and see how this would respond. If this would be operate as an or statement or an and statement. Let's put the get these addresses correctly, and I want to show you the here's D and here's E. How this would respond with these in series. Do you think it would respond as an and statement or an or statement? Let's try this. So now, these guys are on. Let's see here. I gotta press A, which happens to be 6. I think I gotta address some of those as well, don't I? The first input is A. Okay, I do have to readdress some of these. So let's go ahead and go back offline here. Oops, I messed up. I gotta go properties. Come in here, here, make that a 1. B is a 7th input. I don't have a 7 because 7's not used in here. So B, I'm going to use 5. I'm going to change this to 5. I'm going to change that to 5. So you're going to be the 5th, first, maybe I didn't take, I must have messed up properties. Okay, first, the 5th, C's the 3rd input. Okay, and C is still normally closed, and then D is the 2nd input, and E is the 4th input. So I think I've got all the addressing correct now. So first input, 5th input, 3rd input, 2nd input, 4th input. and 3 is a normally closed switch on the PLC, on the push button. So it's a normally closed push button. So I've got this seal-in circuit, so we should be good. So let's go ahead and download this now, see where we're at. Okay, so I am going to close A, which is input 1. And we've got a seal-in circuit. Now, if I press input 2 or 4, I would drop out, correct? So if let's just validate this. Okay, if I hit input 2, it drops it out. I'm going to go ahead and hit start it again. And if I hit input 4, I'm going to drop it out. The request in the lab is to have when both input D and E are turned on. So how do we go about doing that? How do we get D and E both? We got to put them in parallel. A little tricky, not something that that you'd see right away. So let's get this branch in here, and let's get this branch in here. Now, if I hit D and E, I will drop out. Let's see how this goes. Okay, so now I press input 1, seals it in, and if I press data 4, input 4, it does not drop out, right? And then I have to hit input 4 and 2 to get it to drop out. So that meets the requirement of the lab. When both inputs D and E are turned on, we drop it out. So this is a pretty common solution for resetting logic or turning off a sealed-in circuit. So this is something I would expect you guys to see. So when you see a situation where you have two conditions that have to both be met to turn off a coil, this is a very common solution you would run into. So here, the last piece of this, we're gonna I'm gonna change that to hex value of the bits. So we want to enter the decimal value of the double integer. Oh, this is going to be the integer, right? We're not double integer, we're integer 2 and integer 2 here. Okay. So here we're going to enter that decimal value and the hex value. So if we come into this and we look at the tags again, we're online, we're running. The only way we can actually visualize the tags if we're online, we've got to look at what the PLC's got going on, not what the laptop or computer's got going on. We go to integer, word 2, and we turn on that coil. We got to go back. We got to have that on, right? We got to have that information there in order for it to be on. So we hit A, which is input 1. We go back to the tags. What do we have here? We got integer 2 equals an 8320 in decimal. And what does it equal in hex? 2080 in hex. So that is that's those last two questions there. And then if we're looking at the binary levels there, you'll see in bits. It doesn't display the word value, which I thought it did, but I can't seem to get it to display that in decimal. I wonder if I can display it in hex. It won't display it in hex either. And I'm not exactly sure why that value does not illustrate here as the word of binary. Just an Allen Bradley thing, I'm sure. So by using the series of ones and zeros, you should be able to calculate what the hex is, like convert this value from hex. Remember that the bit 0 is the lowest significant bit, and the bit 31 is the most significant bit. Okay, so if I wrap this up with the quiz at the end of this, and there's a few conversions and a couple of quick questions right here and there for the quiz at the end, and that'll pretty much wrap up this week's lab and lecture. Best of luck to everybody. I hope that you have a wonderful week, and I hope everybody's staying safe and healthy. Until we meet again, we'll talk to you later.